In this lecture, we are going to explore a powerful feature called state. React is all about being responsive to the user's interactions, hence why it's called React. The application we've built is functional. However, we haven't taken the best approach to creating a clock. Let's take a moment to examine the current state of our code. In the heading of the page, we created a clock. On every second, the timer gets updated. This effect was achieved by wrapping the render function with a set interval function. There is one major problem with the application. As we saw before, the job of the render function is to render the elements created by the createElement function onto the page. Before it does, it'll check if the elements need to be updated. For example, the paragraph tags from the page component do not need to be updated every second. Therefore, React will not update them on the document. The only element that's changing is the heading. It's a waste of time to render the entire application. It would make more sense to restrict the update process to the heading. Imagine if we have thousands of elements. React would need to check every element before proceeding to update the document. This behavior could potentially impact performance. At most, the render function should run once. React has support for updating a specific section of a page. We can skip checking elements that don't need to be checked. Inside the index file, we're going to remove the setInterval function from our file. The render function should be left alone. Next, let's head over to the header file. This file contains the logic for rendering the clock. This component should be responsible for updating the clock variable without the help of external code. Let's try the same solution again. Below the clock variable, run the setInterval function with an interval of 1000 milliseconds. Inside the function, let's update the clock variable to the date.toLocaleString function. As a reminder, the clock variable should be created with the let keyword. Constants can't be updated. Next, let's look at the page. Despite running the interval, the time never changes. The reason is simple. Functions are executed once. They're not repeatedly called. As a result, the return value of our function is returned once. We can prove this behavior by logging a message to the console. Below the function, let's log a message. StackBlitz has a console for the page that can be opened by clicking the bar below. In the console, our message gets rendered once. Not exactly what we were aiming for. Our goal is to update the template when the variable changes. React doesn't care about our variables. It will not bother watching them for updates. We can tell React to care by creating them as state variables. Throughout your career as a React developer, state is a word you'll hear a lot. State refers to the data for your application or components. Data can be stored in your application as variables. Alternatively, data can be fed into an application from a database. State refers to both types of data. Like I said before, React doesn't care about the clock variable. We can make it care by wrapping the value with a function called react.useState. React has a function called useState. The purpose of this function is to register data with a component. By using this function, React will recognize the data passed into it as important. It'll keep track of the value for you. Inside the function, we can pass on a value. The value can be anything. We can store strings, numbers, dates, objects, and arrays. The useState function will return an array. Inside this array, there are two items. The first item is the current value. The second item is a function for updating the value. Let's log the clock variable. Next, let's check out the console. As you can see, an array has been logged. In the first index, we have the value from the toLocaleString function. The second index has a function. We should never directly modify the array. Instead, this function should be called for updating the value. It'll help React refresh the template for our component. For readability, we should extract this information from the array. It's common practice to destructure the value from the useState function for readability reasons. Let's destructure the value. As we've learned, destructuring an array is straightforward. The first name will be matched with the first item in the array. Let's store the current value under the same name. As for the function, set the name to setClock. It's common practice for the function name to match the previous name. However, it should be prefixed with the word set. This indicates that it's a function for setting the new value of the state. You'll come across this practice often. We're going to follow this practice for the rest of the course. The next step is to update the rest of our component. In the setInterval function, let's replace the variable reassignment by wrapping the value with the setClock function. Let's check out the page. The timer is functional again. Every second, the timer gets updated. Just to make sure, let's check out the console. Previously, we logged a message to tell us if the function was executed. Things will be different this time around. The message gets logged every second, despite not being wrapped inside the setInterval function. By updating the state, React will execute the function. This means our console statement will log a message. It'll be able to update our template with the correct value from the clock. Overall, the useState function helps React keep track of our data. If you would like changes to be reflected in your template, you should store them in a component state, which is managed by React.